Understand the dual criteria of the question. To solve this problem, a student must identify a molecule that satisfies two distinct chemical conditions. It must contain polar covalent bonds, which occur when electrons are shared unequally between two nonmetal atoms with different electronegativities. The overall molecule must be nonpolar, meaning it has a net dipole moment of 0 because its individual bond dipoles cancel each other out due to a highly symmetric molecular geometry. Analyze the bonding and geometry of carbon tetrachloride, CCl4 bond polarity. Chlorine, Cl, is significantly more electronegative than carbon, C. Thus, each individual CCl bond is highly polar covalent, with the electron density pulled strongly toward the chlorine atoms. Molecular geometry. The central carbon atom forms 4 single bonds with no lone pairs, yielding a steric number of 4. This results in an sp to the power 3 hybridized carbon with a highly symmetric tetrahedral geometry. Molecular polarity. Because the tetrahedral structure is perfectly symmetrical and all 4 terminal atoms are identical, Cl, the 4 equal polar bond dipoles pull outward in opposite directions. These dipoles cancel each other out completely, giving the overall molecule a net dipole moment of 0, nonpolar. This makes option D the correct answer. The correct answer is option D, CCl4.